On to part 3, and we're on question 2, but like question 1, there's multiple sub-questions. So as we begin, the first thing we got to take into account is we are solving for all values, right? So that means that all these answers need to have that plus 2 pi n, or in the case of tangent, it's plus pi n. But the first thing we do when we go to solve these is like goal 1, step 1 is get the trig function by itself, right? So we need to get sine x on one side of the equation first. So let's do that. We're going to subtract 3 from both sides, and we see sine x. So minus 3, so that's 2.5 minus 3, so we get negative 1/2. Okay, so we have trig function by itself. The next step that every problem gets is we take the trig inverse. So we take sine inverse of sine of x, and I'll note it up here. So in general, let's sine inverse of sine of x just equals x. That's how we get x by itself. We undo the trig function. So sine inverse of sine x, so like in this case, that's exactly what we have. We have x is equal to sine inverse of negative 1/2. Because remember, what we do to one side, we do to the other, just like we subtracted 3 on both sides. At this point, it looks like the problem's in question 1, where we need to know what angle in the unit circle gives us a sine value of negative 1/2. So let's see, unit circle, negative, so sine is down here. The half means we're somewhere like that. So that's a reference angle of pi over 6, but we're clear over here in the third quadrant. So we have 6 pi over 6 to get to pi, plus another one. So x, lost our pen. Hold on. X equals 7 pi over 6. That's one answer. But we do still have to answer the other reference angle, right? So we're like pi over 6 away from the x-axis here. But in terms of pi over 6's, that is 11 pi over 6. But because we're solving all values, as soon as we go from having a trig function in the equation to not having it, that's when we have to say that we add plus 2 pi n, because we're in sine. And at this point, we have x by itself. We've got our plus 2 pi n disclaimer. So actually, this problem is completely solved. Let's move on to B, see what we get. All right, so here we do have tangent by itself. So this is kind of nice. We just take the tangent inverse of both sides, and we see that x plus pi over 2 equals the tangent inverse of the square root of 3. Okay, and at this point, we just need to say, okay, so x plus pi over 2 equals, well, what angle, where does tangent equal square root of 3? So that's positive, so we're quadrant 1. And we know from our unit circle or from our table that the answer is pi over 3. All right, because the larger angle goes with the larger value, the square root of 3. But again, as soon as we went from having a trig value in the equation to not, that's where we have to start the plus 2 pi n or plus pi n. This is tangent. Tangent repeats every pi. So we solve the tangent inverse. So we got pi over 3. and immediately we put plus pi n. Now, the other solution to this problem would be 4 pi over 3. But if you look at pi over 3 plus pi n, that includes that 4 pi over 3. So at this point, I'm not going to, like here in part A, we had 2 answers. Part B, I'm just going to leave one answer because it's redundant to add x plus pi over 2 equals 4 pi over 3 plus pi n, because that's redundant with the first answer. But we don't have x by itself, so we have to subtract pi over 2, which means we have x equals, if we subtract pi over 2, that's pi over 3 minus pi over 2 plus pi n. So really, pi over 3 minus pi over 2, we have to get those into terms of pi over 6. So that's 3 pi over 6. Right? Oh, no, I'm sorry. That's 2 pi over 6 minus 3 pi over 6 plus pi n. So x equals 2 pi over 6 minus 3 pi over, so x equals negative pi over 6 plus pi n. And that is our answer. All right. Let's erase some of this. See if we can't solve one more here as our time gets closer. All right. Remember, first step, always get sine or whatever your trig function is, get the trig function by itself. Then we take the inverse. So the first thing we got to do is divide both sides by -3. So we find that sine of -3x equals -1. So now we need to take the sine inverse of both sides. So -3x is equal to the sine inverse of -1. The sine inverse of sine just leaves you with whatever's in the inside. So -3x. But what we do to one side, we do to the other. Sine inverse of -1. So what we find is -3x. Well, let's see. Where does sine equal -1? Well, it happens once. We don't have 2 solutions here. We have 1. Sine is -1 at 3 pi over 2. And then for all values, plus 2 pi n. So now we have -3x is equal to some solution plus 2 pi n. We want just x by itself. So if we divide by -3 here, we divide everything by -3 here, what we find is x is equal to 3 pi over 2 divided by -3, or 3 pi over 2 divided by -3 plus 2 pi n divided by -3. So I just kind of broke the fraction so that the first term divided by -3 plus the second term divided by -3. So really x is equal to, well, 3 pi over 2 and then divided by -3. You could look at it as 3 pi over 2 times -1/3. Right, so that's 3 pi over 2 times -1/3 plus 2 pi n. So our final answer is x is equal to -pi over 2. Make sure I'm saying this right. -pi over 2. I'll just say minus, but that's 2 pi n over 3. And I hesitate because The n itself represents all reals, so we're repeating whatever number of pi's around the circle. So if n is positive or negative, I would accept this as an answer, but just for reference, saying plus 2 pi n over 3, that works because n can be negative also. But that gives you answers to A, B, and C. I'm going to end the video here, and we'll work on D and E in the next one.